Hey there, this is Rory, an engineer specializing in PCB signal integrity and power integrity. Simulating critical nets early in the design process is important in order to validate the board stackup, define the optimal design constraints and tolerances, and determine the most efficient termination strategy. I've joined the team design session that Nicole started and can begin simulation with hyperlinks while she continues working on the schematic. Once I'm in Hyperlink's line sim, I can see the net I've launched. After some setup and configuration, I will run the DDRX batch simulation wizard. The goal here is to find the tolerance between the DQ and the DQS nets, and then provide these constraints to my teammates. There's a lot of what-if analysis here, seeing what works and what doesn't work, trying out tolerances and ruling out others. This upfront simulation work that I'm doing will save my teammates a lot of effort down the road, knowing that the timing of the DDR signals are correct and the signal quality is sound. The DDRX batch wizard automates this process and manages all of my simulation results. I can choose the number of bits to be simulated and randomize them, as well as set a range of tolerances in the sweep manager. I'll measure the location of the DRAM and controller at the die and use the JEDEC standards when determining overshoot and undershoot of my signals. Once I run the simulation, I get a nice HTML report, and I can share this with my teammates. Analyzing the report, I can see that in my data write worst cases, I'm passing between 7.5 centimeters and 9.5 centimeters. And then on the data read, I am passing between 6.5 centimeters and 8.5 centimeters. The overlap here of passing to be safe is between 7.5 centimeters and 8.5 centimeters to satisfy both the data read and the data write. Now that I have determined the length matching tolerance, I can provide this report to my teammates as well as export a constraint template for them to import directly into the schematic authoring tool and the constraint manager.